Good day everyone, I am Christine Jodaklan, and for today's video, I will be teaching you how to balance a chemical equation. Now this leads us to the question, why do we have to balance chemical equations? Now to balance a chemical equation, you need to equate the number of atoms present in your chemical equation. Now this simply needs to satisfy the law of conservation of mass. We're going to do a little bit of a recap. So the law of conservation of mass states that no change in mass takes place. The total mass of the product is equal to the total mass of the reactants. So if we are going to balance a chemical equation, we have to make sure that the subscripts or the coefficients present need to be accurate. There are honestly a lot of methods to balance a chemical equation. We have the algebraic method. We also have the trial and error method, and so on and so forth. But we are going to focus on the trial and error method, since this is known as to be the simplest method to use in balancing a chemical equation. Now, how do we conduct a trial and error method? So the trial and error method is a fundamental method of problem solving. It is characterized by repeated varied attempts which are continued until success, or until the practitioner stops trying. So in simple terms, the trial and error method is solving or attempting to find the solution. Repeated attempts of finding the solution. So this is the simplest method to use in balancing a chemical equation. And without further ado, let us apply. So I have here a sample problem or a sample chemical equation. We are going to balance this through the trial and error method. But before that, it is important to know or to read properly the chemical equations or the proper nomenclature of these chemical equations. And so we are going to identify the elements first. We have K. So if we look this up to our periodic table, this stands for potassium. Then next we have NO3 negative. So this is a polyatomic ion which stands for nitrate, combined with hydrogen, CO3, that is carbon trioxide. So combined with hydrogen trioxide, it will yield to. Now this arrow represents the products. So we are going to read this into this will yield to. Then we have potassium again with the carbon trioxide again combined with hydrogen nitrate. So if we're going to read this properly again, potassium nitrate combined with hydrogen carbon trioxide, it will yield to potassium carbon trioxide combined with hydrogen nitrate. Alright, so again, the first rule states that we have to write the correct chemical formulas. So we are going to check if we have written all the elements in the correct formula. So we have potassium, then we have nitrate, we have hydrogen, and carbon trioxide. So we have written them in their correct formulas. Next, we are going to proceed to the second rule, which states that we have to write the formulas of the reactants on the left of the reaction. So this is the left, so meaning to say this is the reactant. So this is our reactants and this is our products. Alright, so we have to again write the formulas of the reactants on the left of the reaction, and we have to write the formulas on the products on the right. So again and again, this is our reactant, this is our product, the left and the right. The next step or the next rule says that we have to count the total number of atoms of each element in the reactants and the total number of atoms or ions of each element in the products. So we have to count the total number of atoms and ions. Now, the ions present in potassium, since there is no number present or number after potassium, that is assumed to be 1. Then we have our polyatomic ion, which is nitrate. Now, nitrate cannot be we cannot say that they have 3 atoms present or ions present, since this is a polyatomic ion. Now, polyatomic ions are single units. So we need to say the NO3 negative has only one total number of atoms or ions. Then let us proceed. We have hydrogen. So hydrogen has 2 ions present. Then the carbon trioxide, rather, I stand corrected. So the carbon trioxide has 1 only, since this is not, or this is a polyatomic ion. This belongs to the gaseous states. Then we have potassium. So potassium here has, the potassium in our product has 2 total number of atoms and ions. Then we have here the carbon trioxide again, rather, I keep mistaking that. So this is the carbon trioxide, we have 1. Then we have also hydrogen, we also have 1. NO3 again, 1. So it is important to note that the polyatomic ion, they have a unique standing here in our chemical equation, since they are considered only to be 1 unless if they were put into a parenthesis, which can be found in another chemical equation. But as of now, they are considered as 1. We are now going to write their subscripts. So the subscript for K is 1, and the subscript for NO3 is 1, again because the total number of atoms or ions present is only 1. Then we have hydrogen, 2. Next we have carbon trioxide. Finally, I got that right. So we have 1. And next we have potassium. In the product side, we have 2. And next we have NO3, nitrate, has 1. And the hydrogen has 1. Their carbon trioxide has 1. There we have our subscripts. Then we are going to proceed later on what is the purpose of subscript, or what is also the rule of subscript in applying the trial and error method. Okay, so we may now proceed to the next rule. We have to balance the element one at a time using coefficients. Alright, so a coefficient is a small whole number that is written in front of a chemical formula in a chemical equation. Now, as you can see, we do not have any numbers before the elements. So since coefficients are the numbers before the elements, right? So we do not have any numbers present before those elements. So what are we going to do? It is important to know that the coefficient, if there are none present, it is assumed to be 1. Alright, so we're going to assume that our coefficients here are 1. So we are going to multiply this to 1 since the coefficients present are 1, since that is what we assume to be present here in our problem. Alright, so we're going to multiply them to 1. You will see later on why I am using a pencil than the marker, because we are going to, as I said earlier, we're going to apply this in a trial and error method. We're going to execute that method, and as of what I've mentioned again, the trial and error method requires a lot of attempts, various attempts. So we have to make sure that our paper is clean, of course, so we're going to use a pencil for that. So I hope it is viewable, so I hope that you can see that properly in the camera. We will now put 1, 1, 1, 1, 1, 1, another 1, and so on and so forth. Then we're going to answer the subscript and our assumed coefficient. Okay, so this will serve as our reactant again because it is on the left, and our product on the right. So 2 times 1, this is 2. 1 times 1, this is 1. Then we have another, again, this is 1. 1 times 1 is 1. And we have 1, then 2, and then 1, and then 1. Okay. Then we are going to check if the chemical equations are balanced. But before that, we have a reminder to everyone, okay? So it is not good, or not necessarily not good, because it is actually prohibited to change the subscript. Okay? So do not change the subscript. Our subscript are the total number of atoms or ions present in our elements. See, we have K, this is 1, so these are our subscript. Notice how I did not use a pencil for that, because I know that these cannot be changed. Okay? So, again, do not change the subscript, okay? We may now proceed to the next rule, which states that you have to check each atom or ion or polyatomic ion to be sure that the equation is correctly balanced. Alright, now we have here 2 and 1, so that is not balanced. Then we have the nitrate for both sides. It is 1 and 1. Okay, so they are balanced. Next, we have hydrogen. For the reactant side, it is 2. For the product side, it is 1. So this is not balanced. So let's put a check mark here since it is already balanced. And then we have here 1 and 1. So it is balanced. So the only elements or the polyatomic ions are balanced, the nitrate and the carbon trioxide. So what we are going to do right now, we are going to alter the coefficients. We can change the coefficients, but we cannot change the subscript. Again, the coefficient, so these are our coefficients. These are 1, 1, 1, so they are assumed to be 1. We can alter them. We can change these in order to balance our chemical equation, in order to make this into 2. We can alter them, but we can never change the subscript. Okay, so we are going to balance this now. This is 2, this is 1. So we have to change the coefficient here in our potassium. We have the power to change that. So we are going to make this as, this is 2. So 1 times 2 is 2. Right, that's great. So the equation is now balanced. We're going to put 2 here on our K. Now notice how this changes everything. Since we have now our coefficient for our nitrate, the coefficient here in our nitrate, since this is located on the reactant side, this will change as well. This is no longer 1, since we already have our coefficient for the reactant side, which is the nitrate for the polyatomic one. This is going to be 2. And 1 times 2 is 2. Then, as we notice, it is no longer balanced, right? Right, no longer balanced. We have to alter again the coefficient in nitrate located here at our product side. Then we shall see if we can balance them. So we're going to change this into 2. Let's place NO3 here. This will become 2. And this will become 2 as well. Okay, so this is check, since they're all balanced. We have here 2, 2, 2, and 2. But then this changes again and again, because we have here our hydrogen. Since we already have a coefficient present, this will turn into 2, which is a good thing because this is already 2. So and here in our reactants, the coefficient is 1, right? The coefficient is 1 and is equals into 2. So before it was not balanced, but right now it is already balanced since we have altered the coefficient present here in our product. So 1 times 2, this will become into 2. And there you have it. So in our carbon trioxide, if we can see, it is already 1. And if we check here, for potassium, we have 2. We have 2, we have 2 again. And lastly, we have carbon trioxide, which is my favorite element because I keep making mistakes. This is carbon trioxide instead of carbonate. So this is carbon trioxide, and we have 1. So they are already balanced. So we are going to check now our coefficients. For K, we have 2, NO3, that is 2. For hydrogens, since that is 1, automatically this will be 1. Then in carbon trioxide, yes, it is already 1. For potassium, we have 1. Carbon trioxide, already 1. And in our nitrate, that is 2, and that is 2. There you have it. We have now our balanced equation. We have our last rule, which states that the coefficients must be, or they are in the lowest possible whole number ratios. Why? Coefficients should be written in lowest possible whole number ratio because they indicate the actual amount of reactants and products in a chemical reaction. So if we are going to try to balance a more complex equation, it is important to reduce them, or they should be written in the lowest possible whole number ratio because they actually signify the actual coefficient present in our chemical reaction. So if we are going to alter the coefficients and not make them or reduce them to the lowest possible whole number ratio, it would mean that, of course, our chemical reaction is not accurate. And there you have it, our final equation for balancing the chemical equation. So we have here 2, 1, 1, 2, our final coefficients. Then here in our trial and error, we have 2, 2, 2, and 1. So that would be all. I hope you learned a lot today. I hope I've taught you a lot of things. I hope that you will now be able to balance a chemical equation. So as I leave to you this video, I would like you to motivate yourself today to learn better and to become better versions of yourself. Remember, just as what Mr. Sir Jonary Bentulan says, that you have to think positive like a product. That would be all. Thank you.